Alright, so this video is going to be talking about perpendicular lines and their slopes. Alright, so what you're going to be doing with parallel and perpendicular lines this week is looking at lines and determining if they're parallel, if they're perpendicular, or neither. I have Daniel, my helper, back. Would you like to say hello again in this video, my darling? Oh my god.
Hello.
Alright, so this is Daniel. He's going to help. He helped out with the parallel lines video. Alright, perpendicular lines are two or more lines that intersect to form a 90-degree angle.
Is 90 degree even a degree?
Yes, 90 degrees is exactly like that.
Okay, like this?
So like a right angle. So like a square angle.
Yeah.
Okay, so, all right, now, why is this important? All right, the idea is, in generic math, when you draw something like this, you're like, great, I have a 90-degree angle, no one cares. But it's important in things like building, because it can be the base of a right triangle, right? And a right triangle we know is a very strong shape. It could be the base of a square, which we also know in building is a very strong shape. So much right angles in there.
That kind of looks like the top of a kite.
It does, it does. And then I was going to say, and then if you move forward into stuff like trigonometry, when you're dealing with 90 degrees, it can have a lot of basis in trigonometric angles as well, all right? So, but we're not worrying about that right now.
Like hand angles?
No, not like hand angles right now. Good idea, though. Okay, so perpendicular lines are two or more lines that intersect to form a 90-degree angle. We use that symbol to show perpendicular, and we need to know about their slopes. And this is a little weird. So, the slopes of perpendicular lines...
Is that a one and a line?
This? No, that's the symbol for perpendicular. Slopes of perpendicular lines are... they're called inverse reciprocals.
Reciprocal?
Yeah, so Daniel's like, what in the world is an inverse reciprocal, right? So if my first line is the number A over B, its perpendicular is going to change sign. So what's the opposite of positive? What's the opposite of plus?
Negative?
Negative, exactly right. So it'll be a negative, and then the reciprocal part is the fraction flips.
Like flipping?
Yep, like flipping. So for example, if I said, oh, my slope was negative 1 over 2, the slope of a perpendicular line, like A over B, the slope of the perpendicular line would change sign, so it would go from negative to positive, and then the 1 over 2 would flip and become 2 over 1. And what will happen then is when you graph those two lines, provided you have more points, you can't just graph with a slope, but what you'll find is they will intersect each other at some point where they form a 90-degree angle. Okay?
90 degree.
Yes, so, sorry, this kid is very into this topic, so, all right. So let's go ahead and let's draw some perpendicular lines, and let's determine whether they're really perpendicular or not. All right, so.
Can I draw some?
No, thank you, sir. I appreciate the offer, though. There's my x-axis and my y-axis. Okay, and what we're going to do is you could like write the equation for this line, but what we care about is we're going to care about what the slope is of this line, because we want to compare it to the slope of this other line.
To that other?
Sorry. All right. All right, Daniel, you ready?
Yeah.
Sorry, Mom's not at school, so her math brain does not work as fast as normal because she's not getting to do as much math. So I really had to stop and think what in the world I was doing with myself. Okay, you ready? So we're going to find the slope of this red line. Now, do those two lines cross each other?
Yes.
Do they cross each other and form what looks to be that nice kind of T 90 degrees? It's hard to tell, right? So if you can't tell, you can't just assume it, even if it looks that way. You have to count your slope. Now, you can do math. You can do the slope form or the slope formula if you want, right? If you are a slope form person. There's also an annoying song for it that has to do with Santa Claus coming to town, right? He's taking y2, subtracting y1. Soon he will find the rise over run. All right? But you don't need the formula if you have the coordinate plane. And that's why I think geometry is nice that way. Because in geometry, generally, you're not going to be given the equation of the line. You're going to be given the picture of the line. All right? So let's go ahead and let's count our slope. Are you ready, Daniel?
Yes.
Okay, we're going to count from here to here. All right? So I'm going to draw my little dotted line. I'm going to draw my little right triangle. How many jumps did I make for my rise?
1.
1. Is it an up one? Or a down one?
Up 1.
Up 1. So I went up 1. Now, how many did I jump to go run?
2.
2. Did I go forward 2 or did I go backward 2?
Forward.
Forward 2. So, my slope for this line is up 1 over 2 or 1/2. If this line is really perpendicular, we will take it and we will find that it is the flip of 1/2. So it'll give us 2 over 1 and it will be negative instead of positive.
Like that one on the top and one on the bottom.
They'll be flipped, yeah. Okay, you ready? So now let's count points. Okay. So now we're going to go from this point to this point. Okay. How far did I rise?
2.
2. Is that up 2 or down 2?
Down 2.
Down 2. Now, how far did I run?
1.
Is that forward 1 or back 1?
Back 1. Forward.
Forward 1.
This is kind of tricky.
It is kind of tricky. Now, notice what I've got is I've got a positive 1 over 2
and then
and a negative 2 over 1. So are they perpendicular? Yes, because they are inverse reciprocals of each other. So, say we gave them names. Say we call this one line L and this one line T. We could say L is perpendicular to T because their slopes are inverse reciprocals. Reciprocal. Okay, so when you're working on my assignment for this week, what you're going to be doing is you're going to be looking at lines and you're going to be counting slope to figure out whether they are parallel, perpendicular, or neither. Because the idea is that leads into more advanced shapes like squares, rectangles, and parallelograms.
Yes.
Right? Only things with 4 sides we're going to talk about, okay? So that, I think, is it for me for perpendicular. Because I think if need be, I might do one where I do just practice examples of parallel, perpendicular, or neither. But for now, parallel is when the slopes are identical. Perpendicular is when the slopes are inverse reciprocals. All right, and it just involves counting, right? If my 5-year-old can count, then you guys can count. You guys know how to do this. You can count. You're fine, right?
I can count.
He can count. See, you got this.
I can count to 110.
He can count to 110. Okay. All right. So, I will talk to you later. If you need help, email me, send me a remind, come visit me in my office hours, send me a message that you can't make my office hours and you need to meet some other time, leave me a message below. Any of those things would work. All right, I will talk to you later.